Okay, in my previous video, I have given a brief introduction about mathematical logic, right? And while discussing that stuff, we discussed certain terms like logic, proofs, theorems, and topics, right? So from this video, we will start with mathematical logic, specifically the propositional logic. Okay, so then gradually we'll move on more complex stuff. Okay, so to understand propositional logic, we need to thoroughly understand what proposition is. So this particular video will be concentrating on the propositions. Okay, now this logics and it's basically these propositions and their different compound propositions, like using some operators we can create more complex propositions. We'll see in future videos as well. The whole mathematics of logic initially developed by Aristotle around 2300 years back. Okay, so now there are other computer scientists and mathematicians as well contributed to this field as well. Okay, we will see, like we or to make it more engaging, we will try to remember them as well throughout these lectures. Okay, so now, to understand the propositional logic, as I said, the first thing we need to understand is what is proposition, right? So let me write it down. Maybe we will try to take a definition of proposition. Okay, proposition. Now, if we talk about proposition, so they're mainly like declarative sentence. Okay, so if I just write it down, so propositions are generally declarative sentence. Declarative, declarative sentences. Okay, declarative sentences. Now, which basically states a fact. It states a fact. Okay, that means when we are saying it states a fact, it could be either true or false, right? It could be either true or false, but can't be both together. Okay, so this is an important stuff. Now, why we study these propositions and all? Because these are the building blocks when you talk about mathematical proof, right? So basically it's nothing but a list of mathematical statements, right? They are arranged in a logical way, right? So constructing a proper mathematical statement is also need to study over here through this propositional logic. So that's why we need to understand and study propositional logic over here, so that we can construct mathematical statement to use for certain purposes like proofing or constructing theorems. So those kind of stuff we need, right? So as I said, so propositions are declarative sentences. This always states a fact, right? They can be either true or false. They cannot be both together. Okay. So for an example, if I just give some example of propositions. Okay. So we can think about propositions like something like this: Delhi is capital of India, right? So this is a fact, and which is basically true, right? So, and it is also a declarative sentence, right? So this is a proposition. We can think about this is a proposition. Now think about this particular mathematical statement: 4 plus 5 equals to 9, right? So this is also a declarative sentence, right? And basically it's a mathematical sentence. Now, and this is also true over here, right? So it states a fact: 4 plus 5 is always equals to 9, right? Now think about this particular stuff: 5 plus 3 equals to, let's say, 7. Now this is a declarative sentence, that is also fine. It states a fact that 5 equals to 3, it's never going to be equals to 7, but that means it is basically a false, right? So it is also a proposition, but this proposition value is true or this proposition value is false over here, right? So let me give you a counter example, certain counter example. counter example of proposition. Okay, so similar way, like if I just write it down over here, which is the capital of capital of India. Okay, so if I just write a sentence something like this one, this is not a declarative sentence, right? This is a question, right? So our first check is not correct at all, so it is definitely not a proposition. Okay, now think about this one, x plus 5 equals to 9 over here. Okay, so again, this particular stuff can be true or false together based on what value is x, right? So that means even though it's a declarative, but it cannot be, it can be true or false both together, right? So which is basically hampering this our point number 3 over here, right? So again, this is not a proposition over here. Now for a certain value of x, which is basically 4 over here, this becoming a proposition over here. In future videos we'll try to see how to deal in this kind of scenario, like how to make a non-propositional statement to a proposition, okay, by using certain conditions over there. Okay, we'll see in our future videos. Okay, similarly, like x plus y equals to z, right? So this is also by using the similar logic, right? So this can be true and false together both, right? Based on the values of x and y and z, we are putting it over here, right? So again, this is not a proposition over here. Okay, so as you have seen, like based on the proposition, like whether we are giving a correct information or wrong information, propositions can have two different values, right? So if I just talk about the values of proposition here, right? So it could be true or it could be false as well, right? So the propositions like which are basically true, we say like their values are true over here, right? And generally propositions in logic, propositions are written as variables over here. Like if I just state, this is how propositions are written. So if I just say p q, this letters are used generally to denote a propositional variable, are used generally to denote a propositional variable. Okay, propositional variable. So that means like if I just say it over here, like p, right? If I just say p is Delhi is capital of India, right? So we can give this particular sentence a name, or let's say we have defined a propositional variable p over here with this particular sentence over here, right? With this particular propositions over here, I would say, right? So this is the way we generally denote a proposition because this type of nomenclature or this type of definition will be helpful in future videos when we will construct more complex proposition from very simplistic proposition. Generally this type of proposition where we cannot break it further, these propositions are also called atomic propositions. Okay, atomic propositions, like these are the propositions we can't break it further. We can't break it further. Okay, so we talked about atomic propositions, we talked about propositional variable over here, we talked about propositions values, right? Truth values. So generally this is also called truth values over here. Okay, now we got, hopefully we got a fair idea about what propositions are. Okay, in next videos we will start working on applying some operators to make a simple proposition or atomic proposition into more complex or compound propositions over there. Okay, hopefully this video is helpful. See you in next video.